going to two proportion confidence intervals. If you didn't like confidence intervals before, you're going to love them now. All right, so we're just jumping right in. We know the situation from talking about sampling distributions. We're comparing proportions of two different populations. We got the same 4 steps as always. State, plan, do, conclude. State what you're trying to find. This is where you will define your parameter. So define parameters here. We'll add that in. Identify the procedure you're going to use and check the conditions. We're constructing a 2 proportion Z interval. Right? Proportions are zesty, so we're going to use Z's. And we got 2 of them now. Step 3, actually construct the interval. And then make an appropriate conclusion about your results. So if you need time to write it down, pause the video. Moving on to conditions. The samples must be random and independent. She is new. Who is she? So not only do the samples need to be done randomly, you need the populations to be distinct. There can't be any overlap. No individual could belong to both groups. So, students at Edgewater High School and students at Bishop Moore, current students, there is no overlap between them. You cannot be in both populations. So they need to be independent of each other. You need the large count condition satisfied in both groups. And you need the 10% condition satisfied in both groups. Conditions, you can take a second on this one, but that's okay. We can do this. I believe in you, and I believe in me. And together we will get through this. It is suspected that women from the Americas are less susceptible to anemia than their African counterparts. A random sample of women from each region is taken. Use the data in the table to construct a 95% confidence interval for the difference in proportion of all women from the Americas with anemia and African women with anemia. Okay, let's go for this. Step 1, state. We want to estimate, hopefully I don't write behind my head. Let me do this. So right there. I'm doing pretty good at that. Okay, we want to estimate P1 minus P2, where P1 is the true proportion of women. Oh, it says difference from Americas and then African, so P1 is going to be in Americas. In the Americas with anemia, and P2 is the true proportion of women. Oh, that says women. Whatever. Women in Africa with anemia. Love that. That's so fun. Want to estimate P1 minus P2 and then define the parameters. Great. All right, step 2, checking conditions. A random sample taken from each region. Great. They're random, and you cannot be a woman from the Americas and be a woman from Africa. So these are 2 random, independent samples. The samples are random and independent. There's condition 1. Next, we usually move to our 10% condition, though the order doesn't matter. It's reasonable. You know what? No, not even it's reasonable. There are definitively more women than that. There are more than 19,000 American women and 21,000 African women. So we can assume independence. Now let me pause and talk about this for a second. These are different independences. In step one, the independence we're talking about is that the populations are independent. The populations do not overlap. This independence is if I draw one American woman out, the probability is not that different for the next one to be selected. So step one's independence is the populations are separate. The second one, the 10% condition independence, means within the sample, my drawing of them is independent. They don't affect each other's selection probability. So they are different independences, and you do have to check them both. If you want to add independence of observations because it makes a distinction stronger for you, you're welcome to do that, but they're different independences. All right, now I need to do... Actually, I need to find p hat 1 and p hat 2. So p hat 1 would be 323 out of 1900, which is, I don't know, I got a calculator pulled up. Let's go to it. 323 divided by 1900. Oh, it's exactly 17? That's crazy. So let me get rid of my approximates. It is exactly 0.17. P hat 2. That's for the African women. That's 840 out of 2100. That should be equals also 840 divided by 2100. That's 0.4. That is a big difference. 0.4. So now I got to do the large counts condition for both populations, or for both samples. So let's do that. Let's do N1 P hat 1, which is 1900 times 0.17. That's 323, which is greater than 10. Now I got to do N1 times 1 minus P hat 1. It's 1900 times 1 minus 0.17. And that should be, girl, I don't even know. 1577. And that's bigger than 10. And I can do the same thing with P2, with P hat 2. So N1, N2, P hat 2 is 2100 times 0.4, and that's 840, which is greater than or equal to 10. N2, 1 minus P hat 2, which is 2100 times 1 minus 0.4, which is 1260. All of those large count things are met, so I can assume the sampling distribution is approximately normal. Love checking conditions in two populations. So fun. So fun. All right, let's do... Wait, go do where I told you to be. Okay. So, I need more space than that. So let's do step 3. I'll do it in blue. Step 3 is the nice one, right? Step 3, I'm literally just going to go put this in the calculator now, and I'm going to tell you what my interval is. So I do a 2 prop z interval. And it yields... I don't know yet because I haven't done it. So intervals are under stat and then tests. I got to just find the right one. There's a 2 prop z test, so that's probably coming up. 2 prop z int. There we go. All right, x1. So the number of successes in the Americas was 323, and their sample size was 1900. x2. I think that was 840, right? Yeah, 840 out of 2100. And the confidence level they told us was to use was 95%. So there it is. Negative 0.2569 to negative 0.203. I think it was 1. Yeah, 1. Oh, I went behind my head. There you go. Oh, why did it go blurry? Anyway. All right, step 4 is to make a conclusion. We are, let me go ahead and do this. So I'm right behind my head again. We are 95% confident that the true difference in proportion of American women with anemia oof, that was bad. And African women with anemia is between negative 0.2569 and negative 0.2031. Now, that is like normal confidence interval conclusion. But when we're talking about two different populations, we want to make a stronger conclusion, right? The difference between these, right? When I did P1 minus P2, or when I was estimating P1 minus P2, my entire interval is negative, right? So I don't have a single possibility. I do not believe that the difference in proportion is 0, which means that I do not believe that they're the same. In fact, since the whole interval is negative, I think this one's bigger, right? I think the proportion of African women with anemia is larger. So I need to make that stronger conclusion. This suggests that African women are more susceptible to anemia than American women, because all values in the interval are negative. You have to make that stronger conclusion. When you have two populations and you're comparing them, you need to actually make the comparison. That's the point of this unit, is I want to compare two different populations. Well, then I better actually make a comparison. That is, that's all I have to say about that. I love you. Bye.